Okay, we're going to skip a little bit of stuff and we're going to jump right into data frames. Just due to time, but don't worry. The things that we're kind of skipping over, Robin's going to go into more detail on day 2 and 3. Okay. So we have data frames at the very beginning of this lesson, and they represent a table of data. We didn't go much further into detail with our example cat data frame. So that's that initial cats one. So cats, do we run that? Right? So there's our initial data frame, cats. So we can now understand something a bit surprising in our data frame. What happens if we run the type of cats? We want to learn the type of data that we have, right? So we know this argument here. So we want to do type of cats. It's a list. Okay. And so what that tells us, we can see that what data frames look like lists under the hood, essentially. Think again what we heard about what lists. Oh, we haven't talked about lists. Okay, lists can be used for all sorts of different types of things. They can be used to organize data of different types. Columns of data frames are vectors of different types that are organized by belonging to the same table. A data frame is really a list of vectors, essentially, like we discussed. So a data frame has each a variable, and each variable is essentially a list of vectors. Okay, and this list of vectors, it's a really special list in which all the vectors must have the same length. And so really, how is this specialness written into the object so that R does not treat it like any other list, but as a table? So first, we're going to want to look at the class of our data frame. So we're going to look at class of cats. We're going to run that. And the output is data frame. So a class, just like the name, is an attribute attached to the object. It tells us what this object means for us humans. You might wonder, why do we need another what type of object is this kind of function, right? We already have type of, which tells us how the object is constructed in the computer. The class is the meaning of the objects for the human. So it means it's a data frame to us. Consequently, what type of returns is fixed in R, mainly the 5 data types, whereas the output of class is diverse and extendable by R packages. Okay, so in our data frames, each row is an observation of a different variable, and thus can be composed of elements of different types. So let's use our string argument again to see those different types. Oops, I'll actually run it. Okay, so in our example, we have an integer, right, that we talked about, a double and a lot. Well, no, we don't have a double. We have a number and a character variable. Thank you. As we've seen already, each of the column in the data frame is a vector. Okay, so that's vectors, that's data frames. We're going to talk about matrices, so matrix. So last but not least is the matrix. And no, not the movie. This looks like a data frame, but it can only hold a single data type. We can declare a matrix full of zeros using this argument here. That will be copied over into the learner notes. So we're going to do a matrix example here. That's what our data frame is going to be called. And we're building a matrix. Okay, so I just ran that. Here it is in our global environment. My global environment is all sorts of messy now. That's where that remove broom function comes in handy. Okay. And then what we want to do, if we want to see what our matrix looks like now that we just built, we want to type in the matrix example. Did I spell example wrong? Example. I did. Okay. Well, you know what? No, I could fix it probably. Here, hold on. Let's see. Let me fix it. Okay. So we're going to do matrix. Okay. Okay, so just ignore the one that's misspelled. And hopefully you just have one that's matrix example spelled correctly. And you know what? I'm going to remove, I'll just give you a little example of getting rid of something in our environment. There we go. Now we just have the matrix example spelled correctly. Okay. Then we also have what's known as a dim function, and it shows us the number of the rows and columns in our data set. So we're going to use, we're going to look at how many rows and columns in our matrix, excuse me. So we're going to do dim, and we're going to do matrix example, and we're going to run that. And it says that we have 3 rows and 6 columns. And again, if you look in your environment, it shows you the similar things here. 3 rows, 6 columns. Okay. Depending on your purpose, a matrix may be more computationally effective compared to using a data frame. So now we're going to jump into exploring the data. And how can you successfully manipulate a data frame, right? So at this point, we toured the basic data types and the data structures. Everything you do will be a manipulation of those tools. But most of the time, the star of the show is the data frame, the table that we created by loading information from the CVS file. In this section, oh man, I do not know how to spell. We'll learn a few more things about working with those data frames. So we're going to talk about adding columns and rows in those data frames. So we already learned that the columns of a data frame are vectors, right? So that our data are consistent type throughout the columns. As such, if we want to add a new column, we can start by making a new vector, which is essentially a list. So let's say we want to add age into our cats data. So we're going to create an age variable, and we're creating the vector that goes along with it, which is that C, right? That's creating the vector, and then our data points. So we'll run that. Now we have another age variable here. And if you type out cats and run that, damn it. Oh no, that's right. It's not in there yet. And then we can add the column by using the cbind argument. Thank you, column bind. So we want to bind the column to our cats data set. We're wanting to add the age variable, right? So we're binding them together. So we'll run that. Type out cats again. Run that. What am I doing wrong here? Hold on one second. There we go. Maybe I just didn't run it, right? I don't know. Anyway, okay. So we ran cats. Oh, that should run that. Huh. I feel like I'm doing something wrong here. Oh, excuse me. Sorry. C-bind, it just adds it into the data when you're looking at it. So if you wanted to look at the cats data set, and then you wanted to look at it with the age variable, you use the C-bind argument for that, and it will show up just like this down here, where it now has that variable age at the end for each of the cats. So note that if we tried to add a vector of ages with a different number of entries than the number of rows in the data table, it will fail. So let's try to add 4 ages, but we only have 3 cats, right? In the cats data set. So, whoops, I want to put it here. Sorry, ignore all this. Okay. So so now we're building an age vector, we're building a vector with 4 data points, but we only have 3 cats. We're going to run this. We've added it. Okay. So now we want to run that same C-bind function again. Dang it. Copy. We want to run that C-bind argument again with cats and age to see if we successfully added it correctly. And instead we get an error. So, and this one says arguments implying differing numbers of rows. So essentially it's telling you you have more data point rows than you have available cats and columns, essentially. Okay. And then it's same if you do the reverse. So let's say we just had 2 data points. And so we can quickly do age. We're going to turn it into a vector of 2. And then we'll run our bind argument, our C-bind argument again. And again, it's saying, nope, there's a different amount of data as there is number of rows. Okay? And so then if you're like, oh my goodness, how many rows are there then? Because now you're frustrated. You want to look it up. Okay, let's see the number of rows then that cats has, because being fickle. 3. Oh, okay, that's why 4 and 2 didn't work. Okay, great. So that's how you can kind of figure out, like, if you're running into these errors, well, how many dang rows do I have? Okay. Okay. Yes. Question. Mhm. Yeah, that's a good question. I think, Robin, are we getting into that more down the, it's next. Okay, thank you. You're just ahead of the game. Slow down. I'm just kidding. Okay, so that is what we're gonna do. Okay, so We're going to get into that next. I'm just looking at this. Hold on. Length. Okay.
Oh.
Someone got it. It clicked. That was awesome. Okay. So, okay, why do I have this here? Okay. If we check, okay, so, and we check the length of that age. Oh, there we go. Okay. So now we want to check the length of the age variable that we just added to see, okay, well, in the row, and the number of rows we have is 3, but the number of data points for age we have is only 2. Okay. So now for it to work, we need to have the n row cats equal the length age, right? We need to have them be the same number of rows and data points. So let's overwrite the content of cats with our new data frame. So what we're going to do here is we're going to fix the age 1, right? So we are going to update our age variable to have the correct number of data points in our vector. Okay. And then we are going to create, we're going to overwrite, sorry, not create. You can create a new one if you didn't want to overwrite it, but we're going to overwrite cat with the C bind argument to combine cats, our original cat, plus the age variable. So that's the answer to your question. So let's run that. And then let's pull up cats and see that it was added correctly, right? So how do we do that again? We just type in cats because that is our data set. And instead of just hitting enter, you run it. And then now I didn't have to do the C bind argument in front of it for the cats plus the age. It just has the age in the table now combined. Okay, beautiful. Love when things work out. Okay, appending rows to the data frame. So now how do we add rows? We just learned how we added columns. We need to learn how to add rows. Okay, so we already know that the rows of a data frame are lists. So what we want to do is we want to create a new row. Okay, new row using the list command. We're going to title this row, wait a second, excuse me. In here are the data sets, the data points. So tortoiseshell, that's the coat, the weight 3.3, true for likes catnip. So it'll either come up as a 0 or 1 depending on which one is true. I think 1 is true. And then 9 would be its age, right? So let's run that. Okay. And then let's then combine our new row into our data set. So our cats data set, right? We're going to use all of our binds. So row binds. And then it's going to be cats, our data set, and new row, the new, and remember, character sensitive. So make sure it's spelled correctly, as we've seen. And then let's confirm that it added. So then we'll type in cats, we'll run it, and yep, we have a 4th row down there with a tortoiseshell cat. Okay. Yeah. And an old cat, yes. Okay. we can also glue two data frames together with our bind. So let's see, we're gonna combine these two data sets here. Okay. And then if we run cats, it now has two. So that's just an example. If we had two, I mean, I did have two others. I could have combined cats too, I guess. But essentially, what I did was I combined two data sets that we had in our global environment using the rbind command, right? And I turned that into a new data set that was also titled cats. And so now we have our cats data set is actually a duplicate because it's a combination of the cats data set and the cats data set. Okay. So challenge. So let's go to the learner notes. If you can copy over the challenge, which probably is already there. Let me see. Okay. So for this challenge, which is currently being copied over, we're going to modify this template code below to create a data frame that holds the following information for yourself. So you want first name, last name, and your lucky number. So what you're doing is you're using the template code to build a data frame, but the data frame should contain your first name, last name, and your lucky number. And once you have the first part done, there's a second and third part you can continue on to. Make sure you're using the stickies if you need help or the X marks. Okay, I'm hoping most have completed the first part of the challenge. Green stickies, if you have. Sweet, sweet. Green check marks for those online. Okay. So let's see what we did here. Ah. There we go. Here we go. Okay. So the data frame, which I'm just going to call DF. Oh, do we have a question online? Oh, that must have just been a mistake. Okay. So I'm just going to call it DF for data frame. And so it might look a little something like this, where you're creating the data frame, your first name, you're creating a vector for it, and it's Grace. Last, creating a vector, Hopper. Lucky number, creating a vector, 0. So let's go ahead and run that. Okay, 3 variables. That looks good. And then we want to add a row for the person sitting next to me. And the person sitting next to me is Marie Curie, surprisingly. And so I'll go ahead and add her to my new data frame by using the row bind, the rbind function. Data frame, right? So that's the name of our new data frame. And we're adding to our list. We're adding another row with these data points. So we'll run that. And then let's check DF and see what we come. Excuse me. Sorry. Okay, let's run DF and see. Great. We got 2 rows. Grace, Marie Curie. She's very old. Okay, and so now we want to know if they enjoy coffee time. And so we want to add that as another column. And to do that, we're going to use our cbind argument to add to our data frame, DF, coffee time, and the vector. We're creating the vector here with our data points. True, true. So then if we run DF again, we should have another column that now has a variable coffee time. Was everybody successful in getting there-ish? I mean, it should obviously have your name and stuff like that. Feeling good? Any places we're getting held up? Okay, I'm gonna give it another minute or so. The key to this is really when you're creating a data frame is really in your parentheses outlining what those variables are going to be and then creating a vector for them. So even if you were creating a data frame with multiple people, like you would just have another person here, you know, comma, Kathleen, you know, so you can keep, you know, and then I'd have another variable here for Kathleen and same for the lucky number. So essentially you're just creating that list essentially. And then here, of course, we used rbind to add another row because we had some data points for another individual. And then we had another variable, so we needed to add a column, and we had those variable points for those two individuals. So that's kind of a summary of what that looks like. I'm going to keep us moving along, keeping track of the time here. So, oh, we got a question, Juan? You got, okay. Okay, so using external data. So far you've seen the basics of manipulating data frames with our cat data. Now let's use those skills to digest a more realistic data set. Let's read in the Gapminder data set that we downloaded previously. So remember when everybody downloaded and saved the Gapminder data set from, okay. So what we're gonna do to read that in is we're gonna assign it a name. We're just gonna call it Gapminder. And then we're going to use our little argument to read.csv. So we're reading a CSV file into our studio here. And then within the parentheses is the name of the CSV file. Sorry, the location and the name. So it's in our data folder. And for me, it's called gapminder_data.csv. Hopefully all the same for you. So we'll run that. And then you can see in my ever-growing environment, Gapminder was read in with 1,704 observations of 6 variables. So we have 6 variables, but lots of data. Okay, so let's investigate Gapminder a bit. The first thing we should always do is we should check out what the data looks like. So we're going to use that string function on our Gapminder data. So string Gapminder. And so it looks like we have an integer, we have 3 numbers, and we have 1 character. Okie doke. An additional method for examining the structure of Gapminder is to use the summary function. This function can be used for various objects in R. For data frames, summary yields a numeric, tabular, or descriptive summary of each column. Numeric or integer numbers are described by the descriptive statistics, quartiles and mean, and characters, columns by its length, class, and mode. So if we use that, the summary instead of string, we can see what I had just described. So let's run that summary on Gapminder. So here it gives you a lot of different information. So you can see how the string, it gave you this information here. Here, summary, it gives you the min, the different quartiles for the different variables. It just gives you a lot more information. Okay. And then again, if we wanted to look at a specific type of data that a specific variable has, like for year, for example, we could do type of that type, remember the argument type of, the data set, $, and then the variable. So we want to look at year. What kind of data is it? It's an integer. So that's the 0, 1s, right? And if we wanted to look at the type of the country in this Gapminder data set, we could do the same thing. It's a character. Okay. So we can also interrogate the data frame for information about its dimensions, remembering that the string command said that there was 1,704 observations of 6 variables in Gapminder. To get just the number of rows and columns in our data set, we would use the arguments nRow and then Gapminder for data set name, right? To figure out the number of rows, 1,704. And then if we wanted to know the number of columns, So this is just another way of exploring your data set, right? 6 columns. So we found various different commands and in our environment, different ways of identifying this information. Okay. There's another argument where you can look at both of those column and row numbers at once, and that's the dim argument. So dimensions. So we're going to do that with our Gapminder data, right? Set, and there you go. When we run that, it gives you both the row and the column numbers. So some other things that we would most likely want to know are what the titles of all the columns are. So we can ask them for later when we're doing our data analysis. You know, you're going to need to know what those variables are named. So there's a couple ways we can do this. We can pull them up using the command column names and then our data set name. And then you can see here it has 6, country, year, pop, continent, life expectancy, and then GDP per capita. You can also use the command names. Gosh dang it. And then our data set. So either one, column names, names. So at this stage, it's important to ask ourselves if the structure R is reporting, if the structure R is reporting matches our intuition or expectations. Do the basic data types reported for each of the columns make sense? If not, we need to sort out any problems now so that it's, which is essentially called cleaning your data. So you have a clean data set to use when you're running your analysis. And again, R has, we can't stress enough of the strict consistency in how we record our data. It's very important. It'll help you down the road. So once we're happy that the data types and the structures seem reasonable, it's time to start digging into our data. And we want to let's check out the first few lines of the data. So to do that, we're going to use the command head and then our data Gapminder, or data set Gapminder. And then that'll show you the first 6 lines and how it's laid out. So it's also good practice to check. We're going to have a little challenge. So if you could copy the challenge over into the learner's notes, this will be, I think, a real quick challenge, hopefully an easier challenge. So it's also good practice to check the last few lines of your data and some in the middle. So use the tail command to do this. So how would you go ahead and use the tail command to check the last few bits, the last few rows of your data, just to make sure everything's looking copacetic compared to your first few rows? Green stickies. Yeah, love it, love it. Green. I'm so happy this was an easier challenge. Great. Green check marks. People on Zooms. Okay. Awesome. Okay. So yeah, let's check it out. So if you guessed that it would be tail Gapminder, you're a genius. And so we can take a look at the last 6 rows of our data, and you can see everything is somewhat looking okay. Yeah. Let's see, hold on. Tail Gapminder, yep. Oh, okay. So if you wanted to check out the middle rows or somewhere in the, or 15 of them, let's see. I think if you want to look at more rows, you just put an N at the end. So it'd be like the tail, gapminder, and then like the last 15 rows. So instead of the last 6, it'll give you the last 15. So if there's a certain amount, and that works for the head as well. So if you want the head command. So if you don't want just the 6, if you want to look at the first 20, the last 20, you know, you would just put that N number there. Okay. Okay. Well, I flew through the rest of that, Robin, and I'm at the ending remarks now. Okay, great. Okay. So I'm going to hand it off to Robin if there's not any last minute questions first. Any other final kind of questions? Okay.